All right, this video is finding the distance on a coordinate plane. Okay, so the essential question today is posted as, how can we use the Pythagorean Theorem to find distances on a coordinate plane? So that's what we're going to be talking about today. All right, so let's recall real quick. The Pythagorean Theorem states that, look, when I have a right triangle, and I know that on a right triangle, that the two legs are called A and B, and the third side, the hypotenuse, is called C. I know that if I take this side and I square it, and I take this side and I square it, I know that it's this side squared. And that's going to be super helpful for me for today. So let's start off with an example. It says, graph the points 3, 0, and 7, negative 5. Find the distances between the two. So I start off and I do that. I say, look, 3, 0, that's here. 7, negative 5, that's down here. I want to know this distance. Well, this creates a diagonal. What I can do is I can go straight down and straight across, and I make myself a right angle, a right triangle, as a matter of fact. And I know that, hey, look, if I'm looking at this, I'm going to notice that by putting these points on the plane, I can create this right triangle, and I'm going to redraw this right triangle on the bottom. But I'm basically showing you that, hey, we started at 0 and it went down to negative 5. So this is a distance of 5. Even though I know I went down, distance is always positive, so it's 5 distance. And then it started at 3 and it went all the way to 7. So 3 to 7, that's a distance of 4. So I basically have this triangle here that's got 5 this way, 4 this way. And I use my Pythagorean theorem to solve the diagonal. I do some math here, crunch some numbers and simplify, and I get 6.4 roughly, approximately 6.4, whatever it is, centimeters, units, however you want to call it. So that's how we're going to use the coordinate plane to figure out distances between points. Now let's notice how we got those numbers. So I'll just redo the same problem, but I want to show you that, look, how did I get this 5 and how did I get this 4? Well, really what I did is, for the blue one here, I took negative 5 and I subtracted 0 from it, or vice versa, right? And that's how you get the distance of 5. And for this red one here, I took 7 minus 3. I said, hey, from 3 to 7, that's a distance of 4. So what I did is I just subtracted. I subtracted the values, okay? We subtract the x values to find the distance, and then the horizontal distance, and then the y values to subtract to get the vertical distance. All right, so that's what I wrote there. X2 and x1 just means, hey, the first or the second point. The first x, the second x, subtract those two. Right? The first y, the second y, subtract those two. Okay, so that's what we ended up doing. And then once we found those two numbers, we plugged them into our Pythagorean theorem. We said, hey, once you subtract these two, you square it. You subtract these two, you square it. That's what those two things are happening. And then after that, we finally square rooted both sides to find the distance. And so basically, mathematicians have figured out, hey, look, there's a formula. You always just take your x values, subtract them, your y values, subtract them, and you square each, and then square root it. And that will always give you, no matter where you are on a coordinate plane, let's say, you know, you're 1 point here, 1 point here. It doesn't matter what it is. Find this distance, square it, add them together, and then the square root will give you the distance between the 2 points. It's called the distance formula. So I want you to go and write down the distance formula. When 2 points are given, x1 and y1, x2, y2, this is the actual formula. You just plug it in. Okay, so take a moment to copy that down, and then let's go ahead and try it out. All right, so let's try it with the distance between these 2 points. Remember, this is the first point, x1, y1. This is x2, y2. So you can even label it x1, y1. This is the first xy. This is the second x and y. All right, once I have that information down, I can go ahead and substitute it into the formula, which is right here. So instead of x2, I look over here, that's 2, minus x1, which is 4. So 2 minus 4. Then over here, y2, that's 2, minus y1, which is 5. I subtract them, and I'm going to end up squaring it. So let's take a look. Subtract that, I get negative 2. Subtract this, I get negative 3. I go ahead and square each of those values, and then add them up. And then last but not least, I square root it. And I find out that my value is approximately 3.6 units. Okay, so I don't have too many examples of that. I just want to show you at least one that you get in your notes, and we'll practice more of this in class.